comes to him and says, we need a new application and it's going to be rather a big one. And our hero does accept challenges. He doesn't have a problem with accepting new challenges. And he's kind of okay with it. And basically this application needs to run in the cloud, and it needs to be reliable, secure, and to scale, and so on. And also it needs to work with the already existing applications that they already have in their environment, right? Okay, our hero never worked with cloud applications, but he wants to know when it needs to be done. And as always, it needs to be done for tomorrow, basically for yesterday. So it needs to be, it's very urgent. Okay, now our hero is very confused, and he never worked with something like that, and now he needs to do it rather quickly, and it's a problem. And of course he feels insecure, and he even starts questioning himself if he can actually build this. But boss has a solution for him. He employed the best consultant in the field. That's perfect. But what really our consultant wants him to do? Basically, he wants to use Kubernetes. Perfect. Kubernetes is a great tool, but really, does it help him if he never worked with a cloud? So basically, he doesn't know cloud. He never worked with Kubernetes, and he doesn't have a time to learn now. So he's starting questioning and doubting himself. Is he good enough? Is he the only one who doesn't know Kubernetes now? So of course he used a few days and to explore and to learn Kubernetes, but of course that doesn't go so easy. And he's working that with his two companions, his two amigos, and at one moment they come with a solution. Why don't you try serverless? So basically that's going to be our topic today, basically serverless way, but not just really a serverless, it's going to be moving from legacy to serverless. But let me tell you something about myself. So my name is Marin Radenović, and I live in Budva, Montenegro. Montenegro is very small country. It's around 650,000, which is probably like a neighborhood of Colombo. And I'm living even a smaller place called Budva. So in all, it's very small. But I'm working as a cloud architect in a Crayon, in the Center of Excellence, Cloud Center of Excellence team. And I'm working in software development for about 17 years. With AWS, I have started around 2014, 2015. But basically, when Lambda went out, I kind of started using that much more and more. And I start liking it. Also, I'm a AWS user group leader in Montenegro. And as Keshava said, I'm also a community builder for serverless. I'm 6 times AWS certified, and all the illustrations that you have seen by now are basically done by my daughter. She's 6 years old. Okay, I helped her, especially when drawing a consultant, but yeah, she did it by herself. Okay, so let's start. But let's start with the basics. What is really serverless? I don't know how much of you worked with serverless at all. I guess significant number, but still, let's start from scratch. What is serverless? Basically, there is a great guy, Gojko Ajic. He is a serverless hero. He is also one of the pioneers in Lambda. He's coming from Serbia. And basically he says, it is serverless as Wi-Fi is wireless. So basically, when you connect to internet over Wi-Fi, only thing that you care really is, do you have internet connection, right? You don't care about, is it really, how is that connected to router, is the cables good or bad. You don't care about what's the throughput of the internet connection. Okay, maybe you do about that, but still you don't care much about the infrastructure behind your Wi-Fi. Only thing you want to know is basically, do you have internet or your phone or not? And in the same way, it's serverless. Basically, you want to know, is your application running, is it scaling, is it reliable? And that's what you want to know about, but you don't really want to care about that much, what's behind that. So this is how you should treat serverless, and basically this is how you should consider serverless. So from technical perspective, so me as a developer, basically I want to focus on my code. I want to develop and focus to produce my code without bugs as much as possible, and with a sufficient quality, so that the users will be satisfied. But let's say from a business perspective, you also want to focus more on your business. You want to sell your application, right? You want to promote that application. So when you fire, let's say, some kind of campaign, and you have 1 million users tomorrow, you don't really want to care about, will it scale? You don't want to care about, did you employ enough people to support your application for 1 million users? You want that to run. So that's how you should think about serverless. But there is also a lots of misconceptions. People say basically serverless is a lambda function. Serverless is a function as a service. Yes, it is, but that's not all. That's not all. It is a pleiades of completely managed service that are serverless. Basically, you don't care what's behind that. For example, when you think of security, you think about Cognito. Cognito is serverless, right? You don't need to care about how it's built and what is behind it. You want to know that your authentication works fine. Same thing applies to S3, DynamoDB when it comes to storage, analytics, AI. So all those things are covered by managed services on AWS. And yes, of course, basically serverless functions, it's a execution when requested. So your application or your, let's say, code runs when you request it and dies when you don't use it, and you pay for that. You pay as you go. But let's say, is it really worth it moving to serverless? So if I have application that works well, do I really want to move to serverless? Well, there are a few things that you should consider, and they're very important in my opinion. So first of all, time to market. When you can focus on your code and you can produce a value quite quickly, you're a much easier able to put something on the market, so that the users can really test it. And that is really good business value, because you are much faster with your product. You're much more advanced comparing to your competitors that need more work in order to push something to market. Also, when you think about availability. Of course, AWS is thinking about the availability in this moment. You need to deploy your application and to know that your code works well. So when you deploy it, AWS pretty much takes care of it. Same applies for performance. So if you fire a campaign of, let's say, and you're expecting 1 million users tomorrow, of course, AWS will scale your application, if it's serverless, to the amount of the users which will come. So virtually, it's scalable to infinity. Even though someone may say that Lambda is basically going serverless is expensive. Well, that's absolutely not true. We're going to talk at the end of the session a bit more in the last slides. But in essence, my opinion is that serverless is cheap, and it is the cheapest you can run your application somewhere. Also about security, your application is secure. Somebody says, let's say it runs on the same hardware with another AWS customers on the same. It runs on the same memory, same storage. It might not be, that secure. Well, it is secure. It is secure. It runs in the special containers, and those containers are managed by AWS. And if you find containers, like if you would push something in a Docker container, it's going to be the pretty much safe. Even I think that it's going to be more safer if it runs, let's say, on Firecracker. So in all, I think serverless is secure. Of course, don't open your application for a public if it's not necessary to open for a public. But you of course there is some liability on you. But like with everything else, right? When it comes to flexibility, serverless is flexible. You can fire so many environments so that you can basically be flexible to virtually indefinitely. So I even had the one example where every commit into the Git was another environment for testing. So basically we had millions of lambdas, so we had to clean them up automated way. But basically we had every commit was a new deployment, which was very interesting. And all of that, when you assume, you basically can innovate quite quickly, which means new features will come to customer much quicker. And you can test your users. You can see if something is if you're flexible in that way. But okay, our hero says serverless sounds great, as a great idea, but how can he apply that in his case? Is it really worth it for him to apply, basically? And there are some things that you need to consider when your application is needs a change. Basically, there are some alarms that you need to consider. If you're very hard for you to innovate with your application, then I think it's definitely time for a change. If deployments are risky, if you need so much support and operations around your deployment, so you're basically collecting features in a bunch in order to deploy them when the time comes, well, that's also something that makes a whole thing much more difficult. And if deployments are difficult and risky, then definitely you need to change something. If it's very expensive to support your application, it's also it's time for change. If you can't keep your stuff, if they're running away, you have application which is, let's say, done few years ago, maybe 5, 6, 7, and nobody really wants to work with it anymore, and keeping the stuff is becoming very difficult. It's definitely time to change. And if you consider all that, then attracting new talents is becoming even more impossible. And probably because you were putting the things under the carpet, you have grown a technical build that probably is gonna kill your application for sure, but it might kill your business as well. So of course, you see that there is a time for change, but that is not that easy. You cannot just replace everything you have built by now, right? And of course, the stakeholders will say, I mean, we cannot invest, let's say, another 2 years in order to build something, and the customers may leave, and probably will leave. So you need to think how how to build that in a proper way, how to do that with some kind of strategy. And yes, if you need to migrate from your legacy applications to serverless, you need a strategies. And AWS does come with certain types of strategies. It's not really connected to serverless, but we're going to come to that. So basically, if you're doing, there were 7 of them, but now there are 6. So they removed a relocation, which is pretty much the same thing as rehosting. And so you have a rehosting, which is basically a lift and shift. You take what you have on-prem and you shift it to the cloud. That's okay way. You have some manual installation, manual configuration, manual deploys, but it's okay if this is the way to go. You can do a replatform. For example, if you had on-prem MySQL database and now you want to go to RDS, this is absolutely okay. You're gonna basically keep the same platform, but you're gonna just move it to cloud, which is totally okay. Repurchasing, basically that's considering SaaS applications. So if you move, let's say, if you're paying licensing on-prem and then you move to SaaS application, that's okay also. But the main thing, if you want to move to legacy, is basically refactoring. You need to concern refactoring, but also you need to think about retaining and then retiring, because as I said, you have lots of data and lots of applications that are running in the current environment. You cannot just get rid of them. There are applications that are requiring data from your application, from your new application, let's say, which is going to run. But there is also a certain data that you would need to use from the already existing application. So basically, you need to work with what you have, with slowly migrating. Let me transfer this through the pets and kettle concept. I'm not sure if you are familiar with that, but that's a DevOps concept where it's basically a treatment of your servers. I kind of changed that a little bit in order to work with migration strategies, but basically a pets is the treatment of your infrastructure. When you say that your infrastructure, when you have a pets infrastructure treatment, basically you're treating your servers as a pet. You have let's say you name them, you exactly know which server needs what kind of attention. One needs to be checked if the logs are basically filling up the storage, or there are some other things that you need to take care, but you exactly know which server needs what kind of attention. When it's cattle, you don't care. You basically just name them in any kind of manner. Basically, just numbering them. You don't even need to number them. You just have some kind of ID on them, and that's it. Basically, you don't care about the servers that you're hosting. And when you translate that into these migration strategies, you're gonna, when you say retaining, you're gonna stay pretty much in the same way as it was before. You're gonna have the same problem. However, when you go a rehosting, then it means that you're gonna, let's say, move your application to the cloud, but you're gonna still having the same issues that you had before with the platform that you had before. When it's replatforming, then it means that a significant number of issues you have moved to AWS. So AWS is thinking about that. And when you do refactoring, you're really preparing your applications to run in, you can prepare your applications to run in the cloud. And this is very important for what's going to proceed next. And when I translate this into the unmanaged and managed service, this is going to look like this. So basically, retaining, rehosting is still significantly unmanaged. So basically, if we talk about cost of ownership, you're still going to inherit some cost of ownership when you do rehosting. But as you're moving to, if you're changing your application or your environment in a certain way, let's say with replatforming and refactoring, you're moving to the managed services. With managed services, you're reducing cost of ownership, at least these operational expenses that you're having. Okay, so what our friend says, basically, if we take virtual machines, instances, and containers, and we treat them like a kettle, then serverless is like a minced meat to me. Basically, you have everything to make a burger, right? You have minced meat, and what you just need to do is just make the burger, make the application, right? But our hero still asks himself, how is all this connected to what he needs to do? I mean, he still has lots of legacy that needs to be worked on. And this needs, this basically is, we are coming now to the refactoring, but refactoring with some additional, sorry. So we're coming to refactoring, but refactoring plus. Basically, we need to do retaining of the existing, some of the existing infrastructure till the moment of the retirement. So we are not get ridding of the, we are not ridding of the existing infrastructure. We're just slowly doing retirement with caution. So when I come to this, I think of divide and conquer strategy, refactoring strategy. Basically, if you have one legacy monolith application on-prem, first what you want to do is to divide that in the current application, the smaller logical parts. So is something that makes sense of you. Will it be a feature? Will it be something that makes a problem currently on the system? Let's say like some bottlenecks that you would like to move to cloud. This is something that you should think of splitting from your already existing application. And basically, when you identify that modules and their integration needs and the required capacity, and when I say this, I say you need to understand what your module needs to consume and what it needs to produce. So if your module is concerning a certain computation and it needs some data in order to produce that certain computation, and that certain certain data that it produces is pumping somewhere else, you need to think what this module, let's say, needs to consume from that on-prem remaining environment in order to know if, because I said a serverless can scale virtually indefinitely, you need to think that this might choke your application. So if your module scales, it doesn't mean that your on-prem environment scales in the same way. So you need to think about that. You need to think how to how much throughput you will require, and also how much are you producing. So for if you're producing and returning back to the on-prem, you also need to know that when you're calling let's say some APIs, they have certain limit on because they are on-prem, and you need to think about how to basically buffer it in a good way so that you don't choke your on-prem application, and also you still satisfy the client so he doesn't experience lag. So basically, you need to design the module when you have all of that into the um, when you have all this calculation done. And when you design it, you need to develop it, test it, and basically when you test it, you need to deploy it. When you deploy it, you retire on-prem piece of the application. So basically, then you say you can securely say that you have moved one module to cloud, and you did it slowly. So this is easy. Okay, it is easy, but our consultant says it's never going to work. And yes, of course, you're going to have a people which is going to doubt this approach, because it's not that easy to be done. And yes, let's go through some challenges that I saw during my work. Basically, there are technical and non-technical challenges. So technical challenges are basically convincing people that they need to do a refactoring on already existing stuff. So when you I'll tell them, well, we need to refactor this piece of the code, they will say, well, it works very well now, right now. Why do we need to take this piece of the application? Why don't we take something else? But at some point, you will need to take a bit more, in order to create a better value. You need to basically extract a significant piece of the existing code in order to create the module on cloud. And you will need to do a refactor of working stuff. Also, it's very hard to convince them that basically nothing is really secure enough. We all so that there was an issue with a Java application recently, and basically it was applications that were working so long in prod now are becoming jeopardized, right? And the security is now really not secure. So you can't say that everything is secure enough because it stayed so much on prod and nothing really happened to it. Nothing is really secure. So basically, you're going to have to fight this. Of course, when you come to a certain a company which wants to do some changes, you're going to face diversity of the applications and technologies, and you'll need to find a way how to integrate those applications. And also, it happened to me that when I come to certain company in order to consult them, I saw that they were in past years they were doing merging of the companies. So basically, when they merge a company, they get their environment. When they buy another company, they get their environment as well. And what they did is just creating some user interface which like integrated with the whole environment, but that didn't work. The data was completely inconsistent. So the customers were buying one product 2 times, or basically they were buying a products on one platform but didn't get what we're expecting on another, and so on. Also, the technical debt. When you have a legacy application, the technical debt is almost inevitable. So you will have to cope with that. Also, environments. When applications grown so much over the years, you will face the problem of testing with the existing environment, because they have 3 or at most 2 environments which you will be able to test. And it may think, because they're producing a new applications by integrating that new features in the parallel with you, with that existing environment, you're gonna step on each other's feet. So that's pretty much inevitable, and you will have this problem. So I'm telling you these challenges because it's good to know that this is something that you might face when you're working with. When it comes to non-technical challenges, you're gonna face different teams with different views, and those different teams are not really fond of serverless, that they don't think it's a good way forward, but there are other guys that would like to learn that, and this is something that's gonna be on you by convincing people what is good, what is not. And of course, some of them follows the waterfall methodology, some of them are following agile methodologies, and also this is something that you need to work with. No documentation, or it's outdated. Corporate politics inside the company. So you have one manager that invested so much years into or product owner that invested so much into one application. Now that application needs to be replaced. So I mean, he's not going to be fond of that. But let's go to some case studies. This is basically most of the diagrams that you're going to see now is basically something that I was working on, and basically some situation that I have solved with the examples that with the strategies that I was telling you about. So basically, this is one approach, very simple approach with the reactive architecture. We had a legacy application, and that legacy applications had a DB, and that DB was pretty much, well, the application is on its end, and we need to migrate the legacy data, and we need to but still we need to retain that application to at least 1 year or maybe 2. But also, in order to build the new applications, we need to listen the data that it comes from that applications. And basically we installed an agent that was listening to transaction logs, and that transaction logs were pushing events into the event bridge, which is event bus, and basically we were able to catch them with different services. Let's say we use step function for some orchestration, Lambda in order to, let's say, transform that data and store it into a DynamoDB for other applications to use. Then also some of the data went to S3 for analysis or similar. Logs for logging purposes into CloudWatch, and then certain alarms with the custom metrics and so on. This is a silent migration approach. Basically we had a legacy application which was pretty much, it died, and we need to transfer that data to the new applications, but as it has a lots of dirty data in it, we had to do it smartly. And basically, as the request comes, we were questioning the database if such data is existing on that system, and if it is, we are gonna push that to DynamoDB. So next time when the user comes, it's not gonna query this legacy database, it's gonna query directly DynamoDB for the same request. This is the same thing, but with Cognito. So if you know, Cognito is having a silent migration trigger. So basically, when the user logs in, it fires Lambda, and that Lambda is able to question legacy application, and that legacy application will respond with the authentication credentials, if it's okay or not, that user to access. And when it is, that user will be sent to user pool, and next time when it comes, it's gonna query Cognito user pool instead of a legacy application. This is interesting approach because of course you have a legacy application, and then some of that legacy application will need to query or basically integrate with your new applications, and some of them are using old technology, or basically you just want to replace old technology that came um, later on, and basically they're working with SOAP. In order to work with the SOAP, you can use API gateway in order to translate the SOAP request into the JSON, and basically use JSON with the Lambda there. And this is or with anything else. This is done in VTL, which is native to API gateway, in order to transform the request on the fly. And basically, this is a good approach how you can integrate some legacy applications with your new applications. This is one interesting case, and it's a rather big one, but the aim was to build a email campaign management solution. And that campaign management solution had to work with already existing application. So we had a CMS, which was working as a beanstalk application on AWS. And we had a CRM for data personalization, which was working which was working on-prem. So basically, through the set of features that those applications already have, let's say CMS could be used to generate an email template, and CRM could be used to extract the personalization data. So by using those systems, we were able to create a new value, or the system which was able to send 10 million emails per day. And with this approach, we have basically replaced the application, SaaS applications, which cost a lot over a month, with a couple of $1,000 per month, with a solution of couple of $1,000 per month, even less probably. This is the scenario where we had a legacy CMS, and that legacy CMS was hooked to a subscription service, and that subscription service could have only one URL. But the modern applications that we were building, the new serverless applications that we were building, couldn't really get those information without modifying legacy CMS. In that moment, legacy CMS, there was no team available to do changes on legacy CMS. So basically, what we did is we hooked the subscription service to API gateway as in events, and then translated that to the event bus. And that event bus basically was able to send the subscription events to Lambda, which was integrating with the rest of the application. But we need to remember that we need to push back to legacy CMS the same information. So basically, we pushed back that information through the SNS. So basically, when event bus fires, you push on the topic that event message, and you're integrating with the legacy CMS. There are on both cases, there are articles that I have written, so you can basically they are described in a detail with all kinds of issues that we faced, so you can read about them if you want. But of course, there must be some drawbacks. That, of course, everything has drawbacks. And of course, somebody would say Jeff Bezos made serverless to be even more richer, right? But I don't kind of believe in that. Not completely, at least. So what is really a bad and ugly with serverless? Most of the people will say, if you go cloud native development, you're gonna have vendor lock-in. But let's read what Wikipedia says about vendor lock-in. In economics, vendor lock-in, also known as a proprietary lock-in or customer lock-in, makes a customer dependent on a vendor for products and services, unable to use another vendor without substantial switching cost, right? That's a switching cost. What's vendor lock-in in cloud? Using a cloud-native services, your application becomes dependent on certain provider. Switching to other cloud provider would require substantial cost. Right. So basically, we are talking about switching here, and it's not really a vendor lock-in; it's a switching. But let's think about what switching cost is. Isn't switching cost if you convert from Oracle database to MySQL in order to reduce the cost, right? Is that a switching cost also? It is a very significant cost. If you're, let's say, moving from Java to JavaScript or PHP to something else, it's a switching cost. And you need to encounter that switching cost. And of course, there are some ways how you can, let's say, escape that. You should do a very well plan and analysis if you want not to encounter that complex problem when you want to migrate for some reason. Even though I don't believe if somebody's good at what they are doing, you should pretty much be safe there. But anyway, let's say you want to move. You need to plan your architecture very well. There is a concept of hexagonal architecture or onion architecture or ports and adapter. It's called in different names, but it's the same thing in essence. Basically, you need to integrate that application. You need to basically wrap your business logic into a module so that you would integrate the vendor locked-in to integrate with the cloud native services through those ports, and those ports can be migrated to something else. So you just migrate those ports, but you're not gonna migrate you're not gonna change the business logic. Also, you need to think about the deployment procedures. But there is also one thing which is serverless expensive? And you know, when somebody says serverless is very expensive, yeah, if you would compare, let's say, 1 minute of instance of the same level with a Lambda of the same level, yeah, it's gonna be very expensive, right? But this is not the point, right? So this is not the point. And serverless is expensive if you wait in serverless. If you call some API and basically wait that API to respond, or basically wait in your Lambda for some reason, then you are paying for waiting. And this is a computation. You need to use for computation, not for a waiting. And if you wait in Lambda, that's expensive. So you try to reduce waiting, use some orchestration tool, use step functions, use something that would basically try to use integrations more in asynchronous than a synchronous way when you're doing serverless. Also, do not max out parameters if you don't need them. I mean, if you don't need to max a parameter just for a case on Lambda, then don't do it. Also, if it's really something that needs, you know, long-running processes, it needs to process, and you don't really have a certain service that's gonna, you don't have a service on AWS in a serverless service on AWS. Use containers then. Use containers. Use Fargate containers, and then that's serverless also. You don't need to manage much there also. Somebody would say that testing is very difficult. Well, testing with cloud native development is difficult, but still it's necessary to test your application. And again, we are coming back to hexagonal architecture. Basically, you can, the integrations that you're planning with services, you can just mock up those integrations in a hexagonal architecture. Then also you can use AWS SAM. You can use SAM. Let's say there is a DynamoDB that you can work locally. There is a API gateway that you can work locally, so you can test your things locally also. Also, there is one interesting thing, a local stack, and it's very interesting. Basically, they try to mock up all AWS services. It's not bad, but be careful. They can't update really all the services in a good manner, because there are thousands of them, and lots of developers are working every day on them. So they cannot really cope with all the changes. So there might be some differences between what is on local stack and what is on AWS currently. So that's it. That's pretty much it, what I have prepared for today. Thanks for listening. So if you're having some questions, I'm here to answer.
Thank you, Marin. If anyone has any questions, you can unmute yourself and ask or put it in the chat. If